Ladies and gentlemen, hello and welcome. Thank you for attending today's webinar, Getting Started with Terraform for Google Cloud. Before we begin, I'd like to cover just a few items regarding this webinar platform. At the bottom of your screen, you'll notice a handful of widgets, mainly the Q&A widget, which you can utilize to submit any questions you have throughout today's webinar session. For viewing purposes, you can also expand your viewing window by clicking on the icon found on the top right corner of the slide viewer. If you have any technical difficulties, please click on the Help widget. And lastly, do take a moment to fill out the survey at the end of the webinar. Thank you. At this time, I'll turn it over to your presenter, Dave.
Welcome. Thank you for sharing your time with me today. I know it's an interesting time we're living in, and I appreciate you all taking the time to be here. So today we're going to talk about Terraform and Google Cloud. Hopefully, what I want you to get out of this today, there's any number of getting started guides that are really good. Hopefully you can get something out of my experiencing this product and using Google Cloud amongst other major cloud providers for several years now. So I'm hoping you'll get more value than just hey, here's how to plug in the right configuration to get started. Hopefully you'll come away maybe thinking about things a little bit differently. So just to kick it off with a quote, this comes from a HashiCorp white about today. That may be scary for some. Maybe some of you are excited about infrastructure provisioning. It may sound boring to others, but that's really level setting what we're doing here. When we talk about the cloud, we're talking on-demand, API-driven, pay-as-you-go. And to really take advantage of that, you need to. Our agenda for today, we have 5 major sections here. The first 2 are going to be mainly slide-driven on the deck here, and then the last 3 will get into some demos. As Olivia mentioned in the intro, you have that Q&A widget down at the bottom. That's a good way for you to interact, ask questions. Got my colleague and friend, Sarah Perry, here. She's going to be moderating the questions, but I'll try and pause and answer questions as they come up. Again, this is your hour and a half, so take advantage of it, ask me questions. All right, so part 1, we're going to look at the cloud operating model. When we're talking cloud operating model, we're really talking the people, the process, and the tools that are involved in managing a modern data center, which includes the cloud, many clouds. Part 2, we're going to look at why you might choose Terraform and how it fits in to that cloud operating model. We're really going to focus actually on the HashiCorp stack as it relates to the cloud operating model and where Terraform fits in there. Part 3, we'll get into how to actually get started with using Terraform and provisioning infrastructure on Google Cloud. Again, we'll start with some low-level things, just configuration, but then we'll kind of we'll grow into it quickly and look at maybe some more workflow and theoretical related things. Part 4 is a section about what I call the journey to Terraform Cloud, and I'll introduce what Terraform Cloud is later, but using my experience, I've kind of seen patterns in maturity as teams and Terraform code bases grow. So we're going to kind of look at the patterns that I've seen there and how you can grow into something like a Terraform Cloud. And then part 5, we're actually going to stand up a Kubernetes instance on Google Cloud from an infrastructure as code pipeline. So the use case here is maybe you're on a team that's already doing some automation, has a pipeline, and the team's decided, hey, we want to start leveraging Kubernetes, integrate that into our pipeline. So we're going to look at it kind of through that lens. A real quick blurb about me and maybe, why you should believe or not believe what I have to say. I'm an architect here at Insight Digital Innovation. I've been with the company a little over 4.5 years. I've been working with Terraform on all projects except my very first one, which was like a 3-month engagement back in January of 2016. So I've been with Terraform since version 0.4. We're just on the release candidate for version 0.13. And I've been working in all the major clouds. So not that I know everything about everything. I've seen some things and noticed some things, and that's really what I want to share with you. All right, so let's look at section 1 here, the cloud operating model. I kind of paraphrased. I read some documents about everybody's kind of got their opinion on the cloud operating model. I define it as a common, secure, scalable model for the modern data center. Looks like I'm just getting a notification my video is frozen, so let me refresh. I'll be right back. One moment. Okay, sorry about that. I hope this doesn't keep happening, but my video froze, so I'm told to refresh here when that happens. Am I unfrozen yet, or am I still frozen? Good old difficulties. That fixed it. Cool, I'm frozen. Let me get all my windows situated here. When I refresh, I gotta reset everything up. Okay, picking back up. Cloud operating. I want to start with some patterns and challenges that I see in IT this year. Some of these have been going on for more than just this year. Maybe if you want to spin it for the positive rather than challenges, it could be motivators. But I've got 3 main buckets. So IT is in the midst of a generational transition. And under that, we've got customers who are demanding value more quickly. And we've got business that is prioritizing digital transformation. And I've actually got a statistic here from a MuleSoft study that says 83% of IT decision makers say increasing IT operational efficiency is a top priority. So obviously big changes in IT, and IT shifting from a cost center to a strategic differentiator. And I think this all kind of rolls up under customers are demanding value more quickly. We're becoming software companies. No matter what industry we're in, we need to reach our customers where they're at. And a lot of that is in an app or online. The second bucket is that the cloud underpins digital transformation. So feeding off the digital transformation is a priority to business. Part of that transformation is adopting the cloud. And that's because you get full-featured APIs and SDKs that you can program against. It's a pay-as-you-go and on-demand model. And you have near limitless scale. And I would add as well that you have transparency in the cloud, cost transparency. Everything's billed, pay as you go per second, per whatever. Transparency that you don't have in the traditional IT data center world. The third is that automation is hard but necessary to operate at scale. So part of the leading with organizations is they're trying to, one, shift left, and that means bringing security in as you're developing products, not as transition into production. Because a lot of times that'll hang up demands or just delay delivering that value to customers, right? And we're integrating our IT operations well. So the folks that are typically responsible for provisioning your static or traditional data center resources and running your application, we're starting to integrate them more. And this is, again, underpinned, going back to that quote, by automation. So in order to adopt the cloud and integrate the IT operations folks, we're starting to automate that infrastructure provisioning. And that's all driven through declarative code or infrastructure as code. All right, not shamelessly, but I hawked this graphic from HashiCorp. I really think it's great, so I want to take a minute to talk to it. It's that generation transition to what we're calling the modern data center, or as dynamic data center. So when we talk traditional data center, we're talking dedicated infrastructure or static infrastructure. I don't think it was a generational transition when we introduced like virtual machines to the data center. It just allowed us to better utilize our dedicated infrastructure. So where the modern data center is different is we still do have that dedicated infrastructure, but now we're calling that private cloud, and that houses our systems of record or legacy stuff. And then we have these systems of engagement, which are built on one or more public clouds. So that's the big shift we're talking about, right? And we need some way to manage this seemingly disparate set of systems, and that's where this cloud operating model comes in. So there's 4 actions that define the cloud operating model as it pertains to the modern data center, and then connect and run. So underneath the provision pillar here, we've got on-demand infrastructure, but we've also got our static infrastructure, those systems of record that we're trying to maintain. We've got to be able to scale, and we want to be globally distributed. The second action or pillar is that we need to secure. So in our traditional center, we kind of have a perimeter-based approach to secure, right? We got firewalls and things that once you're network, we know that you're trusted and safe. But as we move to the modern data center, we're also moving our security to a low trust or zero trust environment where every system I need to get access to, I need to prove who I am, right? And that's why we're moving to more identity-based security. And then the fourth pillar is connect. Again, in your traditional data center, you got IP addresses, DNS, maybe records take hours to propagate. IP address work, things are more fixed. When we move to the modern data center, we're talking about a dynamic networking layer. Things can be provisioned and deprovisioned within seconds. So we can't have something that's going to take hours, like a DNS record, to propagate. And we need service discovery, right? So as we scale up and down or in and out, I need to be able to refer to things that I need access to. And I need a way to discover those and catalog them quickly and efficiently. And then the fourth pillar or action is run. And this is how we deploy and run our applications on the modern data center. So instead of dedicated infrastructure, we're typically provisioning pools of infrastructure, and we're scheduling our applications to run. And that gives us the ability to scale out and in as we need. And we can be dynamic with how those pools are configured, where we can have pools for certain workloads that maybe need more scale, things like that, vertical scale. And we like to package our applications in the environment in which they run together. So that's where containers come in. That is the fourth pillar there. So moving on, Corp actually has a product at each of these levels, and they all tie together and can be very powerful together. But one of the neat things about HashiCorp is they've designed these products to be very singularly focused with a pretty clearly defined set of responsibilities. But when we look at the provision action, we're talking Terraform. When we're looking at secure, we're talking Vault, Connect, Console, and Run with Nomad. The other neat thing that Hashi does is they're really interested in the workflow when it comes to the cloud operating model. So if you're using their full stack, the workflow for all 4 of these is very similar. There's a common thread as well, honorable mention here, and we'll touch on it a little bit later. We've in the enterprise and in certain industries where compliance and governance are very important, there's a common thread that can weave through all these layers for that governance or that policy as code, and that's a product called Sentinel. Just as well to point out on this graphic, I like that, as you see, Terraform here is the base layer. That was intentional. The modern data center underneath, right? So I've got the Google Cloud logo under there, but there's also other squares that could be other clouds, your private cloud, etc. Right? So Terraform's the layer that, the foundational layer built on top of that. Just another view at the Hashi stack. And again, the different products that exist in that stack and sort of functions they perform. Hashi actually publishes on their website they've got a great page called the Tao, which again talks about the singular focus of these applications and how they're Unix-like in their approach, that they do one thing and they do it well. They're interchangeable with other products, and they're really focused on the workflow. So when we talk about adopting cloud, especially data center, having a common workflow is really powerful. So some quick facts about Terraform before we actually kind of get into the use case for Terraform. So I mentioned, and you saw in that diagram, that it is the foundation of the cloud operating model in the HashiCorp stack. One neat thing about it is the command line binary. So the core Terraform product is a single binary file that's an executable that you can run, and it can read in declarative infrastructure templates, which are written in the HashiCorp config language, or HCL. And by reading those in, you connect it to a cloud through a provider, which is a key term we'll talk about later. When you provision that infrastructure, or you declare that infrastructure rather in your HCL, Terraform essentially makes it so, right? So every time I execute Terraform against my declarative infrastructure, I can be sure that the output of that is going to be the infrastructure in whatever cloud or clouds I have configured. There are three forms of Terraform, three terms that are good to be familiar with just off the bat, and we'll go into these more. OSS, so that's product. That is that single binary, executable binary that I mentioned, point one. You'll see that is much more than just a binary. That's actually a whole web front end for managing Terraform and Terraform deployments. It gives you some security wrappers with organizations, workspaces, teams, users. It's a whole product. And then Terraform Init is Terraform Cloud that you can actually install in your own data center or your own cloud, right? So Terraform Cloud is a software as a service or SaaS application that you pay a subscription for. Terraform Enterprise is a licensed product that you install yourself and manage it yourself. And as I mentioned before, Terraform supports third-party infrastructure, including Google Cloud, through the providers mechanism. So provider is a key term in understanding how Terraform integrates in a broader workflow or cloud operating model. All right, moving on. So why might you use Terraform? Maybe some of you already are. We certainly see a lot of interest in it. So NDI does consulting, so I get to work with a wide variety of clients. Is by far and away the most popular player that I've seen anecdotally in this provision space. So, but we'll get into the reasons. I'll kind of enumerate those with each slide as we go. Again, a quote to start this section: Terraform is the lingua franca, or the language bridge, and common workflow for teams provisioning resources across public and private cloud. It's a pretty strong statement, but I hopefully can back that up here. One of the things I get asked is why don't we just use the cloud native templates? So as you go to adopt the public cloud, they're all API driven. They all have SDKs, and every single one of them provides their own mechanism for provisioning infrastructure on their cloud. So in the case of Google, you've got the Google Cloud Deployment Manager template. And if you look at them here, it's a structured YAML syntax, legible. We're declaring infrastructure, right? So it looks like we're building a V1 compute instance, right? And we've got some disks attached and some network. So that's fairly easy to read. You might be tempted, right? Hey, we love Google. Let's just use their templates. What we tend to see happening is maybe 6 months down the road, your company acquires another company and they're using AWS. And they did the same thing that you did. They're like, hey, we love AWS. We're going to use AWS CloudFormation templates. And when we look at this looks a lot different than a Google Cloud Manager deployment template, right? This is more of a JSON-based, lots of quotes and curly braces and colons. Again, we're standing up a VM instance here with a security group and an IP address. But if I compare this with that, if I'm an expert in the Google Cloud Deployment Manager template, I might be struggling a little bit to understand this. Plus, when it goes to actually deploy these templates, the process is going to vary by cloud. Let's say another 6 months go by and we've got a new team within our organization and they're .NET developers. So they're going to favor Azure, which is Microsoft Cloud. Azure has Azure Resource Manager templates. They kind of look like the CloudFormation templates, but not really. And there's some weird functions going on in here in line with our declarative code that I don't really understand. So as you can see, it gets kind of difficult to manage multi-cloud. A lot of you may be saying, hey, well, we're not multi-cloud, right? We're not going multi-cloud. But I think the reality is, and I'll show later, there's evidence that whether we like it or not, we're starting to adopt and having to support as IT or a team within IT, multiple clouds. And there's a bunch of reasons for that I'll get into. So just looking at the various cloud native templates, when you start to look at things beyond just a single cloud, you can kind of see why you may not want to land on just using cloud native template. That same syntax, but using the HashiCorp config language and Terraform, we're seeing, again, we've got some distinct blocks of each cloud with different properties, but our language is the same. We're still using HCL to define it. So our folks, they may have to learn the ins and outs of Google Cloud and AWS and Azure, but they're using the same language to express that infrastructure. And this is a common misconception, I think, that I've seen with Terraform. People think, oh, I write it once in Terraform, and I can just spit it up onto any cloud. So that's a myth. The reality of that is each cloud has their own implementation, but through that provider's mechanism, they plug into that to express that implementation. And I'll, again, in the next slide, I'll kind of get into that a little more. But as you can see, I'm defining a resource in each of them. The Google one's called Google Compute Instance, AWS is AWS Instance, Azure is an Azure Virtual Machine, but they're all very similar. And in addition to the language looking the same, the declarative syntax, the flow is going to be the same. So when I actually go to plan what I'm going to provision and then actually provision it, I'm using a common workflow across multiple clouds. And that's big when you start to bubble this stuff up a level. So you've got your Terraform, right? Something's got to execute that Terraform. And as customers, I see customers mature on their DevOps journey, they pull this stuff up into a pipeline, right? So they're executing this from a pipeline. If cloud native templates from a pipeline, my pipeline definition is going to look different. But if I'm just executing Terraform from my pipeline, I can execute that against multiple clouds, but my actual pipeline code for Terraform is just Terraform. so it's going to look the same. So we're trying to find commonalities in our workflow as we go on this journey. And again, just to reiterate, I don't have all the answers. This is the patterns I've seen, and I've seen how some decisions made early on can affect you 2-3 years down the road, right? And this is just one of the areas where I see it. All right, so syntax is one reason. Second reason that Terraform, why you might want to use Terraform, has this concept of state. So I have a little animation here to kind of illustrate that. So I take Terraform file and I define a resource in that Terraform file. When I apply that using Terraform, it creates that resource in the cloud. Pretty basic, right? That's infrastructure as code, defining resources and actually making it so in the cloud. Now, when Terraform does that, it actually saves what's called a state file. And that is its understanding of what those cloud resources look like the last time it's versioned. It has a lineage to it. It knows how it got to where it's at. And it maintains this state file itself. And you can store this either on the computer where you're executing Terraform by default. You can store it in a remote location so that you can share it. But the gist is, Terraform has some way that it can reconcile kind of what it expects to be in the cloud versus what is actually there. And this becomes important when you talk about day 2 changes, right? So deploying infrastructure is one thing, but going subsequently to either make a change or an update to it, because you're executing against the cloud, and the cloud is a moving bit, you need some way to predict what's actually going to happen. And that's why Terraform uses the state file. So you make a change, or maybe you don't make a change, and you go to run your Terraform later on, beyond the initial provisioning of your resources. It's going to use that state file. It's also going to look at what the reality is in the cloud. It's going to reconcile those 3, and it's going to come up with a plan. That plan is a speculative plan that's going to tell you what Terraform thinks is going to happen when it goes to actually make those changes in the cloud. So plan is not actually doing anything. It's just kind of giving you an idea, hey, this is what I think is going to happen when we go to apply this. And this is important because as we move into this modern data center, and we're adopting multi-cloud, because all these clouds are API driven, it's a moving target. Those APIs are all changing and all at their own rate. Even within the cloud, different resources change at their own rate. This is another reason why Terraform has these providers, because they plug into the cloud and they attempt to keep up with those changes in each cloud, right? A good example, just from anecdotal history, I won't name the cloud provider, but we'd had thousands of resources deployed on this cloud provider when they introduced cloud-managed encryption keys for data disks. So if I've got a virtual machine in the cloud and I've got a disk attached to it, and I want to encrypt that disk at rest, I can have a key up there, an encryption key that I can manage in the cloud that'll, on the fly, it just keeps it encrypted, but when it needs to be read by its virtual machine, it can be decrypted. So this cloud provider rolled this feature out, and they said, hey, we're going to encrypt all your disks by default because we're going to just choose security by default, which is a good practice. What they didn't mean to do was, if you had deployed those disks prior to this encryption rolling out and you weren't using encryption, well, they actually turned on encryption for all your disks. And so in Terraform, we had it defined as, hey, these disks aren't encrypted. And in the state file, it said, yeah, the last time I deployed them, they weren't encrypted. But in reality, the cloud provider had turned on encryption. So Terraform's saying, hey, I can't read this disk, so I'm just going to reprovision it because it's encrypted and it's not supposed to be. Because I can't decrypt it, I'm just going to destroy it and rebuild it. And luckily we saw that, because that was, we had a pipeline and approval gates and all that kind of stuff. But the Terraform plan showed changes to the disk. It's going to destroy and reprovision the disk, right? And then we're like, oh my gosh, why is it doing that? And we had to dig in, and we discovered, hey, the cloud is a moving target, right? The cloud provider did this. I don't think they intended to do this, but this happened and we caught it. So this is kind of what a plan looks like. You'll see you execute the Terraform binary with the command plan, and it's going to, again, look at its state file, look at reality, and look at your declarative code, your Terraform code. And it's going to say, it's got the little yellow tilde for things that's going to change, such creation timestamp here. That makes sense. Timestamp's going to change on subsequent deploys. The green pluses are things it's going to add, and the red minuses are things it's going to remove. So again, this is all speculative before I'm actually making changes in my cloud. So this is a huge thing that Terraform does, and it's a workflow thing that's common across all the cloud providers that's really great to fall into. I've put together this table. I can't take credit. One of my colleagues put together this table that kind of shows the three players involved in what Terraform does. So the players are the columns here. So my Terraform configuration, my state, and then what actually exists in my cloud, and then the operation that Terraform will do. I don't want to get in depth in these. It's just a good thing to refer back to as you start going down your Terraform journey. But one of the ones that I think is interesting, well, two of them, if I don't have code in my Terraform files, and I don't have it, or any resources, I should say, in my configuration file or any resources in my state, but they do exist in the cloud, it's not going to do anything. So that's good to know. I think that's one of the questions I get asked, because a lot of times folks have a box and they may manually provision something and then they want to get it under control of Terraform. Well, if it's not in your Terraform, it's not going to do anything. The second row I want to point out here is if I've got it in my Terraform, but it's not in my state file. So maybe I added it to Terraform, but I never deployed it. And then it's also in the cloud. So maybe it was manually provisioned and I decided I wanted to take it and start managing it with Terraform. But I actually Terraform doesn't have any record of managing it. Terraform by default is going to recreate it, which is kind of a bad thing if I see a lot of folks using stuff in production, trying to pull it into Terraform and, recreating something in production is probably not what you want to do. So Terraform does offer subcommands for dealing with the situation. You can actually import these resources that exist into your state file. And as long as they're in that configuration and in the state file and in reality, then you're going to get a no op, right? So that's the safe way to actually onboard existing infrastructure into your Terraform. So, okay, so state, another reason why you want to use Terraform. Fourth, where are we at? The Terraform open source community is active. So I mentioned the providers. Those providers are actually separate repositories. So this doesn't even take into account all the different providers, which we'll touch on in the next slide. But the core Terraform binary itself, it's got 22,000 stars, almost 6,000 people have forked it. People are opening issues. People are opening pull requests. They're closing issues. You can see a ton of commits, right? So the core product, which is open source, is really active and folks are using it. It's grown like gangbusters, and I've been meaning to look up. I know they secure a ton of, like HashiCorp has secured a ton of VC funding, which is a very popular company right now. And, they operate in this DevOps space and this modern data center space. So they're kind of the epicenter of all this. All right. So in order to interface with the cloud or the modern data center, Terraform has these pluggable third-party things called providers, right? So a provider gives me an interface through the HashiCorp config language to communicate or to provision infrastructure on a cloud. So Google Cloud, Azure, AWS, VMware. These are all official providers that I can easily integrate and start using. There are also non-official providers that I can also use. So IBM Cloud maintains their own. So IBM has a cloud. They don't have a partnership with HashiCorp that allows them to be in the official provider registry. So they maintain their own provider. You can pull it down, use it. You can communicate with IBM Cloud through Terraform. I threw Domino's on here for a couple of reasons, maybe three. Number one, it's cool that you can order pizza through Terraform. Two, to illustrate that the providers are just an interface to an API, right? I'm not provisioning a Domino's store or Domino's infrastructure. I'm just ordering a pizza through their API, but I'm expressing it in Terraform in that HashiCorp config language. And the third reason is this Domino's provider's demoed all the time on stage. So if you ever watch any of the HashiComps, you'll see people ordering Domino's pizza. So I've never actually done this, but you could theoretically put this into your pipeline and order your team a pizza when you do a release, which is pretty cool. So outside of providers, which are the pluggable interfaces to these third-party APIs, you can actually decompose your Terraform into things called modules. So these are like reusable packages of infrastructure. The example I have here, we're going to look at a little later when we stand up our GKE, our Kubernetes on Google Cloud. But the common programming paradigm of it's an interface, that's what a module is. So a module accepts inputs, and it'll take those inputs and provision some infrastructure and then give me some outputs. So it's a good way to decompose your reusable snippets of Terraform and then just call them with a simple interface. This is pretty common as you move up into Terraform Cloud. And I see organizations where they create modules that get blessed by security and compliance, and they're available for other teams to use. So say our team wants to spin up a network on GCP, we might have a module that's sort of a best practices deployment of that, and they just need to feed in a few inputs and it'll output that infrastructure for them. That team doesn't need to understand the intricacies of deploying a network with all of the policies and security groups and routing and all that stuff that especially dev teams don't want to deal with, right? So the power of Terraform modules is I can sort of align my teams with different levels of knowledge and then produce these reconsumable modules or reconsumable snippets of infrastructure in the form of modules. So. All right, so this is the last slide on the why Terraform. This isn't specifically a Terraform thing, but I want to point some of these things out. So this comes from the Accelerate State of DevOps report, which is about every August. It was a group called Dora that Google acquired. So this is from 2019. Obviously, the 2020 is not out yet. But they do a survey-based statistical analysis of different companies on their DevOps journey. And they classify them through lots of testing and statistical things that I don't understand in different levels. So I wanted to point out some of the characteristics of the high-performing DevOps organizations, which as we're going on our digital transformation as companies, DevOps is certainly a huge piece of that, right? So we want to be a high performer in order to succeed. So the first characteristics of a DevOps high performer is they're multi-cloud. So of the folks that they surveyed, they found that multi-cloud usage is up year over year amongst everybody that they surveyed. This is typically fueled by a bunch of reasons. So I mentioned kind of acquisition being one in my example of why you wouldn't choose the cloud native provisioning. But acquisition is a great reason why people are going multi-cloud. We're kind of, I'm not an economist, but after COVID, things are changing and maybe some industries are consolidating. So that with consolidation comes acquisition. So a Google Cloud company might acquire an AWS cloud, a company that they need to now support that. Other reason is availability. So as we have geopolitical boundaries around data and things like that, there may be some functionality that's available in one cloud in a region that you operate that may not be available in another. So you might have to look to adopt a multi-cloud strategy to support that. Performance gains is another one. So, Google is a data company. Google Cloud, their data, their big data tools, BigQuery and things like that, they're awesome. And so if you're doing a data-related project, if it's a greenfield project and you want to start spinning up in Google Cloud, but maybe you're not, that wasn't the primary cloud you were using before, that's a reason to look at it, right? And then flexibility is the other one. Kind of related to empowered teams, which is another point on this slide, but you want your teams to be able to choose the cloud that they want to use, right? So, common pattern. The second point of characteristics of DevOps high performers is they choose tools that influence productivity. Got a statistic here. So not actual companies, but engineers, the highest performing engineers are 1.5 times more likely to have quote unquote easy to use tools. So I'm arguing here that Terraform, relative to the competition, is easy to use. Proprietary tools are concentrated in the lowest performing organizations, while the opposite is true in the highest performing organizations. So that was an interesting statistic, proprietary versus not being correlated to performance. And then this kind of an obvious one, tools with better usability and utility are more likely to be adopted by teams. So again, I would argue because the HashiCorp approach to the cloud operating model is the workflow approach, a common workflow, you'll find that usability and utility is higher, especially once you're already in the ecosystem and within that workflow. It's easy to adopt that to other tools in the stack. Third characteristic is you have empowered teams. So I had mentioned they're empowered to choose kind of their own cloud. They self-organize into communities of practice, right? So you're kind of empowering them. You're letting them make their decisions. So as an IT organization, you need to be able to support that. And tying it all back in to the cloud operating model, we're talking about common workflows, pluggable tools, but trying to keep things, you got to keep things consistent for your own sanity, but you also want to empower your teams. So, and then the fourth characteristic is automation, which, going back to that first quote on the first slide I showed you, it underpins cloud adoption. It is a challenge, but as you automate, you're reducing team stress when it comes to deployment, and you're increasing their confidence. So when we're measuring things like our deployment frequency and our lead time for change, our change failure rate, the more confident we can be, the more we can increase those things. And those things are good measurements of how we're performing as an organization or as a DevOps organization. So I haven't seen any questions come in, so I was going to pause here if there are any. If not, I'll just move on to our next section. This is, again, is all real high-level theoretical stuff, but we're about halfway through, so we can get into demos for the last half. Hopefully that stuff's going to be valuable for you and fun. All right, no questions came in, so let's talk about getting started with Google Cloud. So there are 3 things that I need to tell Terraform to start provisioning infrastructure on Google Cloud. Number 1, I need the provider. So we've been talking a lot about providers, and I said it was a key word. So remember, the provider is that pluggable interface to the Google Cloud API that allows me to write HashiCorp config language Terraform files to provision that infrastructure declaratively. So I need that provider. 2, when I actually execute my Terraform, it's going to execute against a GCP project. So I need to have a project created in Google Cloud. And 3, I need some sort of account that I can authenticate with against my project. I would recommend using a service account and creating a service account key which I can share my screen. We can kind of walk through that. So with those three things, I can start telling Terraform to provision my Google Cloud infrastructure. So let me share my screen out here and pull up my browser. Hopefully you guys will be seeing this here shortly. All right, that's the Terraform homepage. I'm going to flip over here to my Google Cloud. I've got my project here called Davey B, which is a nickname that people give me. And then if I go into my identity and access management from the hamburger menu here, I've got this service accounts. And a service account is a non-user account, non-user account. I don't know the best way to describe it, but essentially I created a service account. It's a way that Terraform can programmatically authenticate against the Google Cloud. I scoped its permissions down to just what it needed. I'm not going to get too much into detail about that, but my general rule of thumb is give it the least amount of privilege that it needs. So I created the service account. I gave it the permissions it needs to stand up the infrastructure that I want to stand up in my project. And then I created a key for it. And then I downloaded that key as a JSON file. So I'll show you that in a minute. It's just a text file in the JSON markup language that includes all the credentials that Terraform needs to authenticate. All right. And then the second piece that I showed, let me flip over to my code editor, was I needed the provider. So I'm using, just a quick aside, I am using Visual Studio Code. I would highly recommend using Visual Studio Code. I'm not typically a Visual Studio Code user, but I think it's good to demo because it seems to be the most popular one. There's a great plugin for it that HashiCorp maintains that'll do syntax highlighting as well as some predictive IntelliSense type ahead kind of stuff. So highly recommend using that. And the repo here that I've got open on the left, this TFGKE 101, this is public. It's up on GitHub. I'll share the link out at the end. But we're working out of this local directory. And then I've got a Terraform file here called main.tf. All right, so that's what we're looking at. Now, so I mentioned we needed our official GCP provider. So I've got my first block here, line 1. This is a block of Terraform or HashiCorp config language where I am configuring Terraform. So I'm telling Terraform, hey, we're going to configure you. So I'm declaring this block of Terraform. And I'm going to skip line 2 for just a second here. We're going to go down to line 3, and I'm specifying the providers that I want to use. Right? So I've got the Google provider in here. This is telling Terraform how it's going to communicate to build these resources. You'll notice that I've got this weird looking devil tail thing, and then some semantic version of the Google provider. I recommend pinning your versions when it comes to interfacing with not only the providers, but with Terraform itself. The little devil tail thing here is called a pessimistic constraint operator. Basically, I'm telling it, all right, I'm pinning the minor version, essentially, in the semantic version. So if we look at major version dot minor version dot patch, I'm saying as long as you're using 3.30 dot whatever, good to go. So I'm not fully pinning it, which I could do with an equal sign, but I'm also not just giving it like, hey, anything greater than version 3.0, because that can cause problems. So just to back up to line 2, I'm doing the same thing with the Terraform provider. So I'm saying I want you to use version 0.12.28, again, using that pessimistic constraint operator. A good anecdotal example here, if I had pinned this at 0.11, or not pinned it, but rather used, hey, 0.11.0 or greater, when Terraform went to version 0.12, they actually introduced major changes, And so I would have potentially broken my Terraform if I'm just using greater than 0.11.0, or even worse, I'm not specifying any version and I'm just YOLOing, or you only live once, for those not down with the leet speak, with the latest version, right? So it's definitely recommended that you pin your versions. Now, you may be asking, where did I get these versions from? And I have an answer for that. So let me pop back over to my browser. So I typically like to look on GitHub. That's the source of truth for me, source of truth for Terraform. You don't have to go this way. You can pull the latest version from HashiCorp's website. But I like to go into GitHub, and I'll tell you why. And I'll show you why in a minute. But you'll see just on the main repo page in the bottom right here, I've got the releases. And I can see the latest release is actually one patch version newer than mine. And I can click in there and see all the releases, so I can get my version number there. Or what I like to do is click on the branch drop down here, and I can go into the tags, and I can actually see in semantic version order all the different versions that I can pick from. And since we're using 0.12.28, I just want to show that I can drop into this commit. And best practice would say that there should be a change log in here. This is why I like to go to GitHub. I can look at the change log, and I can see what's changed. So maybe I'm torn between using 0.12.27 and 0.12.28, and I can actually look at the change log and compare the two. Now, the other one I selected was my provider version. So a couple ways to do that. I can go to the Terraform homepage, terraform.io, which you should be seeing on my screen here shortly. And I can look on the docs drop down here, and they've got a nice section called providers. Click on that. I can see all the officially supported providers. So again, these are all those interfaces into different things that I can communicate with Terraform. And I can click on Google Cloud, and then I can actually see how to configure it, get some instructions. And then from here, I can actually link to the Terraform registry, which is where I was going to recommend going anyhow. I've got that open in another tab here. That's just registry.terraform.io. What's great about there's a bunch of, I love the registry. I highly recommend that. It doesn't have the docs, which is nice about the Terraform homepage, but I can not only look at providers, but I can look at shared modules as well. So those can be published so that you can use them, right, as a good jumping off point. And we'll look at that in a little bit. But under the providers here, I can go into the cloud platform and see the Google provider, the current version, which is 3.31.0. And again, I want to go back to the GitHub source. I can jump into the GitHub repo. All the providers also use semantic versioning. So again, I can go into this branch dropdown, look at the tags, and I can see all the versions of the Google provider that have ever been. We're using 3.30.0, and I can go into here and look at the change log, and I can see what this provider gives me. I think this change log is worth taking a minute to look at because, first of all, the change log is in its own repo, and Google maintains this repo. You'll see in this 3.30.0 version, they now support a new resource, right? So this is, again, highlighting that your clouds are moving targets. And so the providers are keeping up with those moving targets, but it's an abstraction. You're just writing Terraform code. The provider's taking care of dealing with all the API and SDK things on the cloud side. And they're adding support as the cloud adds support for things. So I think that's... So jump back to my code. That's where I got those versions from in the first 6 lines here. Moving down to line 8, I've got my provider definition, or configuration rather. So I've already said I'm using the Google provider, and I've pinned it up under my Terraform config. Use the same version pinning underneath my provider configuration as well. It's flexible. I just did it this way for illustration purposes. But then my provider needs a couple of things. when I was showing you the docs, I'll go back and show you again because I might as well. The docs really give you a description of how to get started, like what's the bare minimum needed to actually start throwing up infrastructure. So they're showing credentials. You need to give it a project, you need to give it a region, right? And that aligns with the three things I was showing you earlier, at least with the credentials, related to credentials and the project. You'll notice I don't have credentials specified in here. This is something I've learned after doing this for a while. I could, like the docs, specify a path to that key file that I downloaded, but I don't know that everybody who's going to be running my Terraform is going to have that same key file in that same location with that same name. So maybe I'd be tempted to just drop the credentials directly into my Terraform, right? Well, my Terraform's on GitHub, it's public. I don't want to put credentials in source code, just as a rule of thumb ever. So I don't have any credentials in my Terraform. What I do have, though, is I am specifying my project and my region. Now, as you read through the GCP provider docs, you'll see that they actually support passing credentials in as an environment variable. That's how I recommend using your credentials to authenticate. So looking at my editor here again, I've got a terminal open. This is my Terraform execution in the local directory. So I'm in this directory. Terraform executes in the context of a working directory. So Terraform is going to read in any of the files ending in .tf or .tfrs in this directory. It's going to determine how best to, what the dependencies look like and how best to provision things and in what order, right? I only have one file, this main.tf. I did that on purpose for illustration. But as you see, as we kind of go down this route to Terraform Cloud, I'll kind of show you how this grows from here. But this is just a very simple example. And if I do an env, so I'm showing my environment variables, and I'm going to grep my Google credentials environment variable. This is a special name that the Google provider knows to look for. If you are familiar with the 12-factor app, I think it's factor number 3 says externalize your config to the environment. That's what I'm doing here. So in this particular execution environment, my credentials are called gcp-sa.json. If I were to move this to another, like a build agent in a pipeline, I can specify able to point to its credentials, right? The idea being is A, my credentials are not in source code, and B, it's portable. So I can support through configuration my Terraform in different environments. Hopefully that makes sense. I'm going to pause there for a minute. I do have a question that came up that I want to look at here. What has been your experience with resource parity between GCP and the GCP provider? Good question. Let me reread that one more time just to make sure that. So what is your experience with resource parity between GCP and the GCP provider? So I think what's being asked here is, as features get deployed in the GCP cloud, how quickly do they show up in the provider? This varies by cloud provider. Google happens to have this magic tool that can take their API and create a provider for it very, very quickly. I can't give you an actual estimate on time, but I can say that the delta between the feature appearing in Google Cloud and actually showing up on the provider is pretty quick. If we look back through the release history, I mean, June 25th, June 24th, May 27th, May 13th. So every week or two, you're going to get a new version of the GCP provider. Everything you want, that's kind of on a per cases basis, but happen relatively quickly. Hopefully that answers your question. So back to our code. I've got Terraform configured to talk to Google, but it's configured. So from my execution environment here, I'm in this directory, right? I'm going to clear my screen. I'm going to run what's called a Terraform Init. And if you'll see, it's downloading the provider. So this is the nice thing with the official HashiCorp supported providers, is I can just specify them in my code and it'll download them. And if you look over in my editor here, I have this new directory called, a hidden directory called .terraform. And down in there, I've actually got my provider that it downloaded for me, versioned. If I'm not using an officially supported provider that's in the HashiCorp registry, I can actually drop my provider in. There are a number of locations I can put it. The Terraform will pick up on it. But that's how you would do that, right? But luckily, Google is officially supported, so it's as simple as adding the configuration here and doing an init. So now Terraform is ready to start communicating with GCP. I'm going to expand a little bit more of the code here because I was hiding some of it. I have a simple example. So we're going to deploy some resources up to my DavyB project. We're going to create a resource. So this is a Terraform primitive. It's a resource. The type, Google Compute Network. You're not going to know this off the top of your head. This is where the provider documentation comes in. So the provider, you know, it is an interface to their API, but they also have documented how you communicate using these Terraform provider types. And then I give it a name. So I'm calling it main. I can call it whatever I want. This is so I can refer to it later. In the documentation, this particular resource type, this network, it has some properties that I need to give it. So I'm giving it a name, calling it demo, a description, and then I am not going to have it auto-create my subnetworks. So that's a basic resource, right? I'm going to stand that up in Google. I want to add, since I'm not having it create networks, and I did this to illustrate a point, I'm going to add the subnetworks. So that's my next resource. So again, resource primitive is, the Terraform primitive is a resource, and the resource type is a Google Compute subnetwork. And again, I'm going to call it main. Looking up the documentation, it's going to tell me what all inputs I need to feed it to give a subnetwork, which I've done here. You will notice, though, this is the one I wanted to highlight and why I did this. There is a property here that actually tells the subnetwork which network it belongs to, right? This is an implicit dependency. So I'm actually referring by name to my Google Compute Network type. And then the name, so I'm using dot syntax here in the name, which is main. And then this thing called self-link, which again, this is an attribute of this particular resource that I can pull out that will allow Google to associate this subnetwork to this network. Okay, so I don't want to get too much into actually, the details of the networking. Just know that we're standing up a network and a subnetwork that belongs to that network, and we're using Terraform. So in the span of, 17 lines of HCL, I'm going to have a subnetwork within this region in GCP. So I'm going to go back to my Terraform execution environment here, where I've got my Terraform binary in here. Just a quick pause and aside. If I just type in Terraform, remember it's a binary. It's going to print the help for all the different subcommands that I can call, which is actually really helpful. And you can dig down into these subcommands as well and get help on those. So what we're going to do, I mentioned Terraform is really powerful from a workflow perspective because I can use the same workflow that includes a plan. It's going to give me a speculative plan about what it's going to do. So here I'm going to run a Terraform plan. I'm going to make this bigger so we can actually see it. So right now, it's reconciling state, which there is none. It's the first time I'm doing this, versus reality, versus what I've declared in my main.tf here. And it's going to tell me what it's going to do. So we're going to stand up a network and a subnetwork, just like I asked for. You'll see the green plus marks, things it's going to add. And then I get this nice digest here at the bottom. It's going to add 2 resources. It's not going to change any resources, and it's not going to destroy any resources, right? So what I'll do is I'll run a Terraform apply. And it's going to start standing those resources up. And you'll notice on my editor right here, it's already created a state file. So that was that local state file I was telling you about that it creates when you execute Terraform, that it uses to keep track of what it expects to be in the cloud since the last time you ran Terraform, and the lineage of how you got there, right? Oh, and I did not specify auto approve, so it is asking me, so it ran a plan and it is asking me, hey, do you want to do this? I'm going to tell it yes. It's going to go ahead and apply that stuff. While that's running, I've got another question that came in. So let me read it. What is your favorite non-cloud Terraform provider? Oh, i.e. random local file TLS. So what is your favorite non-cloud Terraform provider, right? So providers are interfaces to things. And if we go into let me go into the documentation here to answer this question. So we go into docs providers. There's a lot of interesting providers in here. Probably the one I use the most would be the random provider. I don't know that I would say it's my favorite. Where is it here? These are in alphabetical order. So random provider allows you to essentially generate random things. But the cool thing is they have this concept of a keeper. So if I have a random number, but I don't want it to regenerate every time Terraform runs, I can attach it to another resource, and that resource is its keeper. So whenever that resource changes, then my random number can change. And this can be used for a lot of cool situations. I've used it a lot in tagging. If you want like a created on tag on your resource, but you don't want it to, keep updating every time you run Terraform, you can create a keeper on that resource and like a random string to output in combination with the timestamp. So you can always have just an actual created on tag. So that is that question. I got another question. What is TF YOLO? I think I said that Terraform, you only live once, right? So anytime you only live once, you're just pushing stuff to production. That was a weird question, but okay. I think I answered that. I don't know. All right. Anyhow, back to my command line here where we're executing Terraform. So I created this infrastructure, right? So we defined it, we applied it. It spit out some stuff, which I didn't talk about. I'll show in a minute, but it basically spit some helpful information. This output also goes into the state file. So it's useful for reference later, or maybe reference from other processes that may have access to your state file. They can read this information and use it. It's a good way to pass things dynamically from one Terraform run to another. Although if you do it too much, you get into this crazy dependency thing that you probably don't want to get into. So I don't really want to get too much into that. But let me jump back to my Google Cloud console here. And this is under networking. So you'll see our network demo down here at the bottom, US East 1 with our subnet. Yay. So we've now successfully provisioned infrastructure on GCP using Terraform. This is a very basic example. And again, my hope is that you're getting out sort of my process for this rather than actually how do you stand up a network, right? So just to touch on the outputs, those are a different Terraform primitive that I can name, and then I can specify the output in whatever format I want. And I'm referencing, again, attributes of the reasons that I'm standing up. And those get printed out, standard out, and those get thrown into the state file. This is a good opportunity to talk about security of your state file. And we'll also talk about, in the next section, the journey to Terraform Cloud, right? So one of those things in the journey is your state file. Right now, the state file is on my computer. It's unencrypted. There could potentially be sensitive information in plain text on this state file, right? So as a secured asset, when you're just doing development, getting started like this, it's okay. But anytime you're getting into something in production or working, at a larger company, you definitely want to make sure that you're taking care of your state file. So, all right, let me drop back into the deck here. That demo. Any questions? So that's kind of an important foundational thing to getting started. But before I start moving on to less introductory things and more jumping sort of up the different tiers of maturity, does anybody have any questions that they want to ask? This time is yours. We've got just a little bit of time left here, 20 minutes. I'm trying to keep this interactive. All right. Well, in the interest of time, we're going to move forward. Okay. So I'm going to jump back into the screen share and talk about modules, but we're going to use it in context of those subnets and that network we just created, right? So looking back at my screen, when it loads up here, you should be seeing it. We created everything in this main.tf file, right? Well, I've got another directory here called modules. So as companies mature in using Terraform, maybe the teams expand, they start breaking their Terraform files up into multiple files. Right? So maybe I put, in this case, I created a variables file. So maybe I want to expose my project ID in my region as an input. So maybe I want to use the same Terraform across different projects, different regions. I've created a TFRs file for this particular execution that's going to get pulled in with the same project ID and region that I used before. And then I've got my main.tf here where I've got my provider, again, that same configuration. But instead of defining the resources here, I've got a different Terraform primitive called a module. And I'm using I can name it whatever I want. And I'm sourcing it from a directory relative to where Terraform is going to execute. This is not best practice, but this is what I'm doing for illustration purposes, so don't judge me. Let me drop back into my terminal here. I'm going to queue up a destroy here while I'm waiting on that. So this module is actually contained within the subdirectory. And it's got a number of inputs defined as variables here. So it's going to input region, a couple of network ranges. And then inside of this module is that familiar looking Google Compute Network and Google Compute Subnetwork, right? But instead of just hard coding my region, I'm referencing my variable with the dot region. I'd input variable.primary CIDR range and variable.secondary CIDR range. So the net effect is I've taken what is this network config and sort of abstracted it out through a module, and I'm sourcing this module from a relative path to where my Terraform is going to be executing, right? So let me go back into that directory. So I'm in that directory. Again, I'll do a Terraform Init. And I'll do a Terraform plan. I'm not going to apply this time. This takes too much time. And you'll see the net effect is, though I am calling a module, the actual output is the same. I also should mention output of the module here is the same, but I do have to bubble that up from the calling template, right? So if I want to output that to, it's kind of like an error in any programming language. I've got to bubble it up to the surface. So I'm referencing the output from the module. Don't want to get too much into detail about how modules work. Just know that you can source a module locally. That's pretty common for younger teams that expand and maybe more people are using them and they want to simplify some of that more complex infrastructure. The next level up would be using sourcing from Git. So let me show you that. I'll back out here and go into Git, clear my screen. Same kind of deal. I'm feeding in some inputs, but instead of sourcing it locally, I'm actually sourcing it from this own. It's this repo. I'm using this Git special Git path syntax that Terraform understands. So Git : this is the URL of this Git repo that we're in right now. I'm using this other special syntax, the // to tell it to go into the modules directory, into the Git directory, into network, which is this guy down here. So again, very similar to what I was doing with the local module, but now it's in a repo. Why would I do that? Well, if you look at this, these are like get parameters. I'm referring to a particular version of the repo. So as I want to start versioning my modules, I can actually refer not just to my main branch, I could refer to a release or a commit or a tag, whatever I wanted to do. That's the power of putting this into Git. Now, what you find is you'll start creating a Git repo for every module, and you'll have Git repo sprawl. And then discovery can be a little challenging, but that's kind of where I see customers going as they, again, mature. They're starting to use those modules more, and they're looking to decompose and break them down and make them reusable and versioned. The net effect, again, if I run a Terraform Init, notice I'm using the same workflow. That was kind of why I structured it this way. Terraform Init, Terraform plan, same deal. Building my network, building my subnetwork, but instead of sourcing my module locally, it's sourcing it from Git, right? So that's as far as I'm going to get using the Terraform open source. And that's where we start to see customers needing to go toward Terraform Cloud. So let's drop back to the presentation here. So I tried to graph this, as you'll see as my presentation comes up on the screen. This is a, there is no y-axis here, but this is basically trying to show the number of modules that you use and the types of modules that you use and kind of where we start to recommend using Terraform Cloud. So with that, you're probably asking, well, what is Terraform Cloud or Enterprise? So Terraform Cloud is a front end to Terraform, right? It has a UI. It's huge. This is not just a small thing, right? It's a front end to the Terraform open source, but it's a whole UI wrapper. So you can log in. You've got a user account. You've got, I'll get into this. You've got organizational level namespacing. So you've got some security boundaries within Terraform Cloud. So I can set up organizations. I can align those however I want. Within organizations, I have teams. I can assign users to teams, and I also have workspaces. Workspaces actually correlate to a Terraform state file. So a Terraform execution creates a state file. That's kind of how I think of workspaces. I don't know how Hashi describes them, but when I create a workspace, I get a place to store my state file securely. And it's going to execute that Terraform and store that state file there for me. It is a Terraform execution environment. So as we talk about executing things in a pipeline, right? I'm not just calling Terraform locally when I'm trying to do this in a repeated fashion. I need to execute it in a pipeline, so I need a build agent. So that's what I'm getting with Terraform Cloud and Terraform Enterprise. I actually have an execution environment for my Terraform. I mentioned that it stores your state file securely. It also stores secrets that I might need as inputs into my Terraform. And those are backed by another HashiCorp product called Vault. When we, again, going back to that cloud operating model, the secure pillar, right, that's Vault. So it's a secure storage backend for my secrets and my state file. It takes care of all that for me, which is super nice. Out of the box, I can configure it for integration with my version control provider or my version control system, and it will do some GitOps for me. So I don't actually even have to configure anything other than give it access to my repo, and it can start doing some of those integrations for me. I'll show that to you shortly. And then it also offers the Sentinel policy as code framework. So I mentioned the common thread that goes through the Hashi cloud operating model. And that is policy as code via Sentinel. That allows me, if I have governance that I want to requirements or compliance requirements that I want to ensure exist in my infrastructure as code and in my running applications, right? I can weave those in with these Sentinel policies. What's nice about Sentinel is that it runs as part of your plan when you run that Terraform plan. So it integrates into that workflow, right? It's very workflow driven. Terraform Cloud is a private module registry. So I was showing you how I could source my modules from Git. With Terraform Cloud, I have a private place to host my modules. that it doesn't have to be public, and that I can version a little bit cleaner, and that I can surface for discoverability within Terraform Cloud to other teams within my organization. And to highlight the GitOps, hashtag GitOps integration that comes out of the box with Terraform Cloud, if I point it at my repo and I say, hey, I want you to auto-apply my Terraform, when I open a PR to the main branch of that repo, Terraform is going to inject a speculative plan into my PR so I can see before I even merge what's going to happen. And then when I do merge, if I've enabled auto-apply, it's actually going to apply that Terraform for me. So it's kind of abstracting the workflow a little bit, but it's integrating it in sort of a best practices manner. Now, this is great for organizations that are just getting started with some of their automation and pipelining. I typically see more of a GitHub or a Git-driven workflow where pipelines are orchestrated outside of Terraform Cloud as you mature. But this is a great way to get started, and that's included with Terraform Cloud and Terraform Enterprise. Quick touch on Sentinel. I mentioned it's just governance left, integrates the Terraform plan. Nothing new there, although you can kind of see an example of sort of what a policy might look like. So I'm closing in on time, so I wanted to get into my GKE from IAC pipeline example. So we're going to deploy Kubernetes onto GKE, or on GCP rather. So Google Kubernetes Engine. There's a lot that goes into it, right? You need a network. I need a pool of compute nodes spread across multiple zones for HA. I need instance configuration stuff. I need an auto-scaling group. I need service accounts. I need monitoring, logging. The list goes on, right? It's pretty complicated. What's nice is Google has published a module for Terraform that I can consume. I feed it those inputs, and it's going to spit out a Google Kubernetes Engine instance for me. That's what this is. So Terraform modules to the rescue. So essentially, I'm feeding it the various inputs, and I'm referencing the module, which I've stored up in my own Terraform Cloud instance, a version of that module, giving it those inputs, and it'll stand it up for me. So I kind of want to just get into the demo since we're running short on time. So I'm going to kind of gloss over these slides. Going back to my screen here. So I had mentioned that this was all up on GitHub. So please dig around in this afterwards. They're going to share the links with you. It'll be in the slide deck as well. Here's where I've got, this is the repo we've been working out of. Here's where I've got the module call. So again, very familiar syntax that we've seen as we were learning modules. I'm sourcing it from my Terraform Cloud instance, and I'm sourcing a particular version of that module, and then I'm feeding it a bunch of parameters. These are the bare minimum parameters that I wanted to stand up the Google Kubernetes engine the way I wanted it. The other piece that I have here is I have this integrated, since I'm not, I'm integrating the situation I was envisioning here was that I'm already on a team, they've already got a pipeline, right? So in this case, I've got a GitHub action that's already deploying Terraform, so I want to integrate into that. The point here is that I'm not going to use the native VCS integration in Terraform Cloud. I'm actually going to just use Terraform Cloud as an execution environment to deploy my GKE. So from Git, from my pipeline in Git, I'm actually going to call Terraform Cloud to execute my Terraform plan on a PR, and then my Terraform apply when I merge, okay? That's at a high level what we're doing. So if I drop back in, this is that same main.tf that I was showing you. I need to disable this, but okay. Let me go ahead and clear my screen. I'm going to check out the main branch of that repo and just pull the updates. So let's say I wanted to create a new feature to add spaces. Oh, I already created that one. Add spaces 1. I want to make some change to this file, so I'm adding returns, I guess. Right, so I make some change. Did I add those? I did. Okay. I'm going to commit that. So add important spaces. And I'm going to push this branch to my repo. And I'm sorry I'm flying through this. I just ran short on time because I got to talking. So now I pushed this branch just where I added spaces to that, right? I'm going to create a PR, add important spaces, PR back into main. I create that pull request. And you'll notice, it'll take a second, it's going to kick off this, this pipeline. And this pipeline is actually going to run on my Terraform Cloud instance, run a plan for me. So I can drop into here and look at it running. So this is running against my Terraform Cloud instance. One of the other nice things that Terraform Cloud gives me, it's still in development, but it's going to spit out a cost estimate. Like, what is this going to cost to run in the cloud? Which is super cool. I'm not worried about the build agent here, right? Because I'm using Terraform Cloud's build agent. So it's already got the version of Terraform configured that I want in there. It's managing my state file, my Google credentials as an environment variable into that execution environment. So everything's nice and secure. This is a public repo that I'm doing this in. All the pipeline code, it's all in there. And you'll see it's going to spit out my plan here, tell me what to expect, right? And then as soon as this finishes, we'll go back to the PR. It's actually going to inject that plan into my PR. So I go back to here. You'll see it, GitHub Actions here at it. Here's my plan. Actually copy this URL. The plan ran inside of my Terraform Cloud instance. I can go dig in on it there if I wanted to. If there were problems, I wanted to troubleshoot something, I can see the plan there. Drop in back. When I merge this, I actually have it set to go ahead and apply as well. So I'm going to merge that. It's merged. Delete my branch. Just clean up after myself. If I drop back into my runs here, you should see a queue up to actually stand up GKE. So refresh. Well, I'm going to pause there, and I guess we have, what, 5 minutes left? Sorry, I had to rush to the end there. But questions? Okay, well, we're right at the hour, so no questions came in. Thank you. Again, I apologize for rushing at the end, but please check out these links to learn more about, learn more about how to get started with GCP, the providers, Terraform Cloud, GKE, and then as well as all the assets that I showed you for the demos in this presentation. So thanks, everybody.
That concludes today's webinar. A big thank you to the presentation team today and to the attendees. Thank you for the time and opportunity to come together. With that, we'll turn you back to your day. Thank you.